this up later on. Okay, so once again, let's do the problem. What frequency does a wave have if its speed is 100 meters per second and its wavelength is 2.5 meters? So let's see what we've got. Let's see what we're given. Let's see the equation, then we'll see how we can solve for what we're looking for. All right, we're given speed, S, is going to be 100 meters per second, right? So that is our speed that we've got. And the wavelength is 2.5 meters. Recall that wavelength is represented by lambda. That's 2.5 meters. So what we're looking for is the frequency. That's what we don't have. Our equation is speed is equal to frequency times wavelength. So pretty easy, right? All you do here is you're given speed, plug that into there. You're given wavelength, plug that into there. And you're looking for frequency. So just solve it. So I'm going to go ahead and plug in. The speed is 100 meters per second. It's going to be equal to, we're looking for the frequency, okay, times the wavelength is 2.5 meters. Okay. So we're looking for frequency. All right, so we want to get this by itself, which means we want to get rid of everything else on the right-hand side. So let's get rid of the 2.5 meters. It's me multiplied by 2.5 meters, divide by 2.5 meters. And since we did it to the right side, we have to do it to the left side. But by going ahead and getting rid of the 2.5 meters, by dividing by 2.5 meters, you get rid of it on the right-hand side. So the only thing that we have left now is the frequency. So frequency is going to be equal to, now this is where your calculator comes into play, 100 divided by 2.5. You take 100 divided by 2.5. You're going to get 40. Okay. So you're going to get 40, but 40 what? What units? Well, turns out that you'll notice that the 100 had meters per second as its units. The 2.5 in the denominator had meters as its units. So what we're going to do is we're going to have the meters in the numerator cancel out with the meters in the denominator, leaving us with just 1 over seconds. But we saw that those are the units of frequency, right? Per second or 1 over second are units of frequency. So this is our answer. Our frequency here is 40 per second. Or you can write it as 40 hertz. Because 1 hertz, a hertz is equal to a meter, is a wave per second. Not a meter per second, but a wave per second. Or you can even write it as 40 per second. Second to the negative 1 power. That's the same thing as the inverse of seconds, 1 over second. So either of these ways of writing the answer, any of those three ways of answering the question would be fine. Okay? Any questions on this first sample problem? Okay, let's do a little bit harder one. The second one we're going to do is, new paper here. What frequency does a wave have? Oh, sorry, that was the first one. What wavelength does a wave moving at 5,000 meters per second have if its frequency is 25,000 hertz? 25,000 hertz, right? That's 25,000 waves in 1 second. That's a lot. All right, so we're looking for wavelength here. We're given, speed, which is 5,000 meters per second. We're given frequency, which is 25,000 hertz, or I'm going to put it as 1 over second. And you're going to see why later on. Hertz is a nice way nice unit to call a frequency, but when you're using equations, you want the units to be in per second because it's easier than to have the units cancel out. And we're looking for the wavelength. So once again, same equation. Speed is equal to frequency times wavelength. This time, we are given the speed. Thank you. We are given the frequency, and now we're looking for the wavelength. Okay. Now, last time we went ahead and plugged in the numbers and then solved for it, right? This time I would do something different because the numbers are starting to get a little bit bigger. Okay? And later on we're going to have scientific notation numbers, which get a little more unwieldy. So what I'm going to do is this. I'm going to move the letters first, then plug in the numbers. Okay? So let's do this. I want to solve for wavelength. That's what I'm looking for here, right? Wavelength. So what I'm going to do is I'm going to go ahead and divide both sides by frequency to get my wavelength by itself. Since I want wavelength to be by itself, it's being multiplied by frequency. So what I'm going to do is I'm going to divide both sides by frequency. When you do that, now your frequencies cancel on the right, and you're left with speed over frequency is equal to wavelength. Okay? And so that's basically just reorganizing the problem, the equation. And now I just plug this in. A wavelength is just speed over frequency. We just have to plug in these numbers once. So the speed is 5,000 meters per second. Thank you. And the frequency in the denominator is 25,000 per second, or hertz. See how I just had to plug that in once? I didn't have to divide by 25,000 to both sides. And so I'm going to get 5,000 divided by 25,000. If you plug that into your calculator, 5,000 divided by 25,000, I get 0.2 as your answer. So 0.2. So 0.2, and you'll notice that the units are going to be meters because the units of the numerator are meters per second. The units of the denominator are per second. So we're going to go ahead and cancel out the seconds in the denominator of the numerator and seconds in the denominator of the denominator. Those guys get canceled. We're just left with meters. So 0.2 meters, there's your answer. And that's how you do a problem like this. Alternatively, I could have gone ahead and plugged in 5,000 here, plugged in 25,000 here. What I would have done is divide by 25,000, which means I would have to have written 25,000 3 separate times. Not a big deal, but this seems a little bit cleaner if you move the letters first. But whatever you feel most comfortable with. Any questions on this problem? Okay, let's do the last one. The last one's, the question is, what frequency does a wave have if its speed is 3 times 10 to the 8th meters per second and its wavelength is 6 times 10 to the minus 6 meters? The purpose of this problem here, you'll notice we already did one where we solved for frequency. Why are we doing it again? The first time we solved for frequency, the numbers were kind of relatively small. There was no scientific notation. It was just 100 and 2.5. It was just getting you guys used to using the equation. But once we start dealing with light, we're going to be using numbers that are really big and really small, and they're all pretty much in scientific notation. So that's why I want to go ahead and do another problem where it solves for frequency. Okay, so let's go ahead and do that. So what are we given here? We are given a speed of 3.0 times 10 to the 8th meters per second, which, by the way, is the speed of light. So that is the speed of light. And its wavelength is 6.0 times 10 to the minus 6. 6.0 times 10 to the minus 6 meters. That's actually kind of a little bit large for light, even though it's a very small number. And what we're looking for is the frequency. So once again, like last time, we're going to start off with our equation. S is equal to frequency times wavelength. And if you, since they're being multiplied together, if you put wavelength times frequency, that's fine too. But as I said, it's a little cleaner if you move the letters around first, then you plug in the numbers. Although you're welcome to plug in, this number for speed and this number for wavelength. But then you're going to have to divide both sides by this number and basically write it out 3 times. So what I'm going to do is I'm going to move the letters first. We are looking for frequency, so I want to get my frequency by itself, which means I need to divide both sides by wavelength. Divide both sides by wavelength. Now the wavelengths cancel, the lambdas cancel on the right, leaving me with an equation that the frequency is equal to the speed over the wavelength. Okay. And then whenever you're looking for frequency, you can just plug it into this equation. So that means take the speed first, 3.0 times 10 to the 8th meters per second, and divide by the wavelength, which is 6.0 times 10 to the minus 6 meters. Okay. That's going to give us our frequency. And if I plug it into the calculator, 3.0 times 10 to the 8th divided by 6.0 times 10 to the negative 6th, what I get is 5 times 10 to the 13th. 5 times 10 to the 13th. So that's going to be our answer. 5.0 times 10 to the 13th. And you'll notice that the units, like in the first one, meters cancel here with the meters, leaving you with 1 over second. So 5.0 times 10 to the 13th per second is an answer. You can also write it as 5.0 times 10 to the 13th hertz, because remember that per second is a frequency, but so is hertz. Okay. And that's how you're going to do your worksheets. Any questions? Okay.